Hi guys, and welcome to another video. It's been a while, but here we are. We're back and we are back at it. So let's get going. We're looking at grade 10, paper 1, exemplar, question 1 from the exemplar paper that you have. And I'm looking at question 1, and this is saying simplify 2x minus 3 times 3x squared minus 4x plus 1. So this is a binomial. Yeah, and it's times a trinomial. Okay, so we're going to multiply 2 terms times 3 terms, so we're going to end up with 6 terms. And then remember that after we open out these brackets, we need to add and subtract like terms. Okay, what makes like terms quickly? Remember that like terms have the same variable and the same exponent or same power. So we only consider the coefficients when we are adding and subtracting like terms. Okay, so we will get to that just now. 1.1.1. We're going to look at that first question. 1.1.1. Let's write the question down again. And we got here 2x minus 3 into 3x squared minus 4x plus 1. And now we're going to multiply. So we're going to distribute this 2x here into the bracket. So we got 2x times 3x squared. And we're going to get 6x cubed. We're going to multiply 2x times minus 4x, and that's going to give us minus 8x squared. And then we're going to say 2x times plus 1 is plus 2x, so that's plus 2x. Negative 3 times 3x squared is going to give us minus 9x squared. And minus 3 times minus 4x is positive 12x, and minus 3 times plus 1 is minus 3. So we've opened out the brackets, and I told you that when we multiply a binomial times a trinomial, 2 terms times 3 terms, we're going to end up with 6 terms. 1, 2, 3, 4, 5, 6. Remember, terms are separated by plus or minus signs. They are joined together by brackets, which is multiplication and division. Okay. Now, we need to add the like terms. So the like terms here would be, let's identify the like terms. The like terms will be x squared there, minus 8x squared and minus 9x squared. And also the like terms here is positive 2x and positive 12x. Those are our like terms. And then we simply just bring our other terms down that don't have any other like terms to add or subtract to. So minus 8x squared and minus 9x, only look at the coefficients. Minus 8 added to minus 9 is minus 17x squared. Think about integers there, right? And plus 2x and plus 12x is plus 14x, and then minus 3 is our constant, which just comes down. So after adding and subtracting the like terms, we are just left with 4 terms, okay, all unlike terms. Okay, so that's our first solution there, binomial times a trinomial. Let's look at our next question. And in our next question, we have a question on exponents, simplification of exponents there. And that's 4 to the x plus 1 times, remember dot means times, 3 to the x minus 1 all over 12 to the x minus 2. And we're going to simplify this expression here, 1.1.2. Let's get to that. So let's write the question down, 1.1.2. And let's write 4 to the x plus 1. So we got 4 to the x plus 1 times 3 to the x minus 1 times 3 to the x minus 1 all over, what do we have here? 12 to the x minus 2. So we got 12 to the x minus 2. So here, 12 to the x minus 2 equals to. Now, the thing about exponents, when you are working with exponents and simplification of exponents, we need to look at the bases and we need to identify them now or write them as prime bases. Like 4 is equal to 2 squared. 3 is already a prime number. 12 is equal to 4 times 3, which can be represented as 2 squared times 3. So 4 we're going to write as 2 squared and 12 as 2 squared times 3. It's important for us to remember that we must write all our bases as prime bases, okay, when dealing with exponents. So we got 2 squared to the x plus 1 times, remember dot means times, 3 to the x minus 1. Okay, so we've got that. And here in the bottom, we're going to be left with we said 12 is going to be 2 squared times 3. 4 times 3, which now gets simplified to 2 squared times 3 to the x minus 2. So now what's going to be left for us to do is to open these brackets out. So which rule are we using here? If I got x to the m raised to the power n, it's going to be x to the m times n, or x to the mn. So you're going to multiply now, okay? So let's multiply. So we're going to get 2 to the 2x plus 2 times 3 to the x minus 1. So we're just using this rule here to open out our brackets. And in the bottom here, we've got 2 to the 2, and here we got times x minus 2. So now don't forget, now you must multiply 2 times x and 2 times minus 2. So you're going to get 2x minus 4. So 2 times x is 2x, and 2 times minus 2 is minus 4. And then don't forget, now there's a 1 there, right? Okay, the invisible 1. And then you got times, remember dot means multiplication, 3 to the x minus 2. So 1 times x is x, 1 times minus 2 is minus 2. Let us we've now, as you can see, we've opened out our brackets, okay? Now we're going to use a rule which says that if we are multiplying, see, like x to the m times x to the n, that's equals to x to the m plus n. A law of exponents that we're going to use here now to simplify this. And then we're using this rule over here as well, which says that if I got x to the m divided by x to the n, it's equals to x to the m minus n. So we also need to use that rule. So let's see how we use that rule effectively. So let's identify all our bases. Remember, the bases have to be the same for us to use this rule now. So we're going to say 2 to the 2x plus 2. So we're starting here. 2 to the 2x plus 2. And then where else we got 2? We got 2 there as well. Can you all see that? Okay, that's important for you to understand. And then, but we're dividing. So you're going to say 2 to the 2x plus 2 divided by 2 to the 2x minus 4. So now what you're going to do is, remember that it says the top minus bottom, m minus n. So what we say now is we're going to change these signs here in the bottom when we're writing it. So it's going to be minus 2x plus 4, because now you're subtracting, you're saying minus into 2x plus 4. So one time now we can simplify and just write minus 2x plus 4, okay? So just double check that, make sure you understand that. We're applying the rule, okay? And then here we got 3 to the x minus 1 all over 3 to the x minus 2. So that's going to be 3 to the x minus 1. Once again, because you're dividing now, you change the signs of the bottom exponents here. Okay, so you're going to get minus x plus 2. And let's see what we're left with now. So we're now going to be left with 2. So 2x minus 2x cancels, that's 0. And then we left with 2 plus 4 is 6. So we got 2 to the 6 times. X minus x cancels there. And we left with minus 1 plus 2, which is 1. So we got 3 to the 1. Learners, so we left with 2 to the 6 there. Okay. And we are also now left with times 3 to the 1. So you can use your calculator here if you want to. So you can write here 2 to the power 6 times 3, remember 3 to the 1 is 3, right? Equals to 192. So we'll write our answer 192. And that's our answer there. Okay, so that should be it. 192. Let's look at our next question. Factorize fully. So here we got factorize fully. Got 3x squared minus 2x minus 5. And that's a trinomial. Remember, we must learn all the different types of factorization. So this is one type of factorization that we do in grade 10. There's 5 that we need to know. So 1.2.1. Let's look at 1.2.1. Let's write the question down. And the question there is now 3x squared minus 2x minus 5. So we got 3x squared minus 2x minus 5. 3x squared minus 2x minus 5. Now, to factorize a trinomial, so we normally classify this as a type 2. Now, some of us, we can do this by inspection if we're doing it for a long time. It takes us a couple of tries, but we can use a trial and error method, okay? If I have to just do it by inspection, I will just do it like this. 3x, it's a prime number, so it'll be 3x times x. So there's only two factors of 3, 1 and 3. So it's 3 and 1. So 3x times x is 3x squared. 5 is also a prime number, so it's not a very difficult question, but it's still a type 2 question, which takes a little bit of trial and error here. So I got two factors, 1 and 5. But remember, I need to get my middle term, which is minus 2 here, minus 2x, okay? So I won't put the 5 here at the end because I know if I multiply 3 times 5, that's going to be 15. So it's better for me now to try putting the 1 there and putting the 5 there and checking whether this works. Okay? Now, how will this work now? It'll only work. Remember, I need to get minus 2x here in the middle term, and I need to get minus 5 here in the end as my last term. So for me to do that now, I'm going to say minus 5 and plus 1. So if I check by inspection, 3x times x is 3x squared. Then minus 5 times plus 1 is minus 5. So I've got my first and my last term. It's only my middle term now that I need to get. So if I say minus 5 times x minus 5x, and then the outer terms, 3 times plus 1 is plus 3x. And if I add those two up, I'll get minus 5x plus 3x is minus 2x. So now I got my middle term. Always check your factorization by products to make sure that you get the correct answer. So there's the answer there. The answer will be 3x minus 5 into x plus 1. Another way, another technique that you can use is if we multiply our first and our last term. 3 times minus 5 is minus 15. Then I look for two factors of 15. When I multiply, I'm going to get minus 15. But when I add, I must get negative 2. So that will be plus 3 and minus 5. Plus 3 and minus 5 added together gives me minus 2. Then my first term is 3x squared. So I want to drop the squared. I only want to write 3x here on top. 3x, right? And then if I simplify now, by looking for HCF, I want to simplify the fraction. 3 goes into 3 one time. 3 goes into 3 one time. So I got x plus 1 here. Remember, I write it like that. And then, I can't simplify the 3 and the 5. So my next factor there now is going to be 3x minus 5. See, x plus 1, 3x minus 5, 3x minus 5. Okay, that's another technique that you can use. Remember, this was minus 2x there. Okay, so that's how we can factorize a trinomial. Stick to the method that you know and understand. Okay, practice, practice, practice. Next question is 1.2.2 minus xy minus into y minus x times b plus b squared. So here, this looks like a question on grouping. If we open out the brackets, we'll get 4 terms, right? So let's see. So it looks like a question on grouping. So let's have a look. 1.2.2. Okay, so let's look at question 1.2.2. And in question 1.2.2, we have minus xy. This looks like a grouping in pairs question. Minus xy. And we've got minus into y minus x. We got minus into y minus x times b. And we also have plus b squared, So we got plus b squared. Now, why does this look like a grouping in pairs question? Because if I open these brackets out here, I'm going to be left with minus xy. Remember this b, I can put it in the front there, or write it as minus b into y minus x. It's the same thing. So all of that there is the same as that. I just rewrote it. So it'll be minus by plus bx. Y plus bx, minus times the minus is plus, b times x is bx. And then we got plus b squared. So we got minus xy minus by plus bx plus b squared. So let's see, grouping in pairs, right? So grouping in pairs here now, firstly, let's take out here, we can take out minus y in these first two terms here. You can see minus y, what we left with now? We're going to be left with x plus b. Always check your factorization by products. Minus y times x minus xy. Minus y times plus b minus by. And here we can remove b there. So we got b, and what we're going to be left with? X plus b. So now we can finish off this. So x plus b is common. So we can remove that as a common factor. X plus b into minus y plus b. Minus y plus b. Or you could write your answer as x plus b into b minus y. It's the same thing. If you left it like that, it's fine, perfectly okay. So that was grouping in pairs. Let us remember with factorization, only two types was tested here, okay? Grouping in pairs and trinomials. You need to know 5 types of factorization. Okay, so in this particular question, question 1 of our exemplar, and learners go through it, try answering the questions first before looking at the solutions, and I will see you in the next video.